going to see the part 3 of HSFC solutions. Okay, so we are going to see some of the problematic questions in this video. Let us see what is the first question. The values of R, L and C in a series RLC circuit that resonates at 1.5 kilohertz and consumes 50 watts from a 50 volt. That is 50 watts of power it is consuming from a 50 volt source, AC source operating at the resonant frequency. The bandwidth is 0.75 kilohertz. So you need to find the values of R, L and C. Okay. So that is a question. This is a series RLC circuit type of question. So we have already done a detailed video on the resonance series RLC circuits. What is the value of what is the equation for finding the bandwidth, the resonant frequency, quality factor, how the R, L and C components is connected and its value is varying. So all these things we have already discussed on a detailed video. So I'll share that link in the description box. Okay. So in this question, we need to find the value of R, L and C. And also I have written here all the equations needed for answering this question. The first one is a very basic equation that is actually a general equation, not really related to this particular question, but this is a general equation of power. Power is equal to voltage square by resistance. That is a general equation. Here it is being given that it consumes 50 watts power from 50 volt source. So the voltage value is being given, the power value is being given. So from that we can find the resistance. So hence we will get the value of resistance, right? Next we need to find the value of L, that is inductance we need to find. So for that you can use the equation for a resonance circuit bandwidth equation. Bandwidth is equal to R by 2 pi L, where R is the resistance value, L is the inductance value. Here bandwidth is being given, so you can directly find the L value. Okay, R value will be obtained from the first part. Then the third one we need to find the capacitance value. For that you can use the equation for finding the resonant frequency, which is F0. This is the value in hertz. So it is 1 by 2 pi square root of LC is the equation for finding the resonant frequency in hertz. Here it is being given that it resonates at 1.5 kilohertz means F0 is given, right? So F0 is given. Here L will be obtained from the second part. Hence you can find the value of C. So this is how you need to approach these type of problems. There are not much complicated equations when connecting to the resonance circuit. There are only very basic equations. You just have to apply some of your basic knowledge and then choose the equations right, and you have to find the value. Okay, so that is the thing we need to do. So first I am going to find the first part, which is I am going to find the value of resistance. So the equation is P is equal to, I'll write it once again, P is equal to V square by R. So from this R is equal to V square by P. So what is V? This statement you have to use. Consumes 50 watts from 50 volt AC source. So 50 volt it is. So 50 into 50 by power is again 50 watts. So what will be the answer? It is nothing but 50 ohms will be the value of resistance. Okay. The basic theory of resonance circuit I have explained in that video. Please do watch that video. Okay. So R is the resistance value we have obtained. We'll draw a figure here. R, L, C. So we have obtained R as 50 ohms. Okay. Next we need to find the value of L and C. So first I'm going to find L now. What is the bandwidth? Bandwidth equation, I'll write once again. Bandwidth is equal to R by 2 pi L. It's equation. So substitute the value of bandwidth 0.75 kilohertz, that is into 10 raised to 3 hertz, is equal to R is 50 by 2 into pi into L. So from this L is equal to 50 by 0.75 into 10 raised to 3 into 2 into pi. If you solve it, you will get 10.6 millihenry will be the value of inductance. So now I can write the value of the inductance also here. It is I'll write it above. 10.6 millihenry is the value of inductance. Okay, so it is a simple question. You need to find the value of R, L and C. Next, the third part, which is the last part, I'm going to find the value of capacitor. I need this equation actually. I've removed it. I'll write once again. So, you have the L value and R value now. You need only the C value now. So, for that I am going to use the equation for resonant frequency, that is F0 is equal to 1 by 2 pi square root of LC. In order to remove the square root, just take the square on both sides. So, F0 square is equal to 1 by 4 pi square L into C. Here L value is known, F0 is known. Directly you can find C. So, I am going to write the equation for C is equal to 1 by 4 pi square into L into F0 square. Okay, so what is the value of F0? It is 1.5 kilohertz it is. Okay, so I'm going to substitute it. Okay, I'll write it above. C is equal to 1 by 4 pi square into L value is 10.6 millihenry, that means 10 raised to minus 3 Henry into F0 square it is. F0 is 1.5 into 10 raised to 3 the whole square. It is 1.5 kilohertz. So 1.5 into 10 raised to 3 the whole square. So if you solve this, you will get the value as 1.06 microfarad is a value of capacitance obtained. Okay, so the capacitance value is obtained as 1.06 microfarad. So we have obtained all the three values and we just need three equations directly to solve this question. So this is the value of R, L and C. Okay, so the answer is R is equal to 50 ohms, L is equal to 10.6 millihenry and C, which is a capacitance, is equal to 1.06 microfarad. Okay, so this is how you need to solve these type of resonant circuit questions. When the VSWR is 3, what is the value of reflection coefficient? So this relation between VSWR reflection coefficient is very famous and a lot of questions are coming from the VSWR section of microwave engineering. So the relation is this. VSWR, which is voltage static wave ratio, is actually happening due to the reflections from the load side. Okay. So this VSWR, again I have done a detailed video on VSWR. I will share that link also in the description box. If you want to know about what is VSWR, what is its relation with the reflection coefficient, all those things, please do refer that video. So VSWR is equal to 1 plus reflection coefficient by 1 minus reflection coefficient. Now the reflection coefficient, if you take from this equation, the reflection coefficient can be written as VSWR minus 1 by VSWR plus 1. So this is a very simple relation between VSWR and reflection coefficient. So this question is actually asking the reflection coefficient. So you have to use this relation. Reflection coefficient is represented using tau, which is VSWR minus 1 by VSWR minus 1 by VSWR plus 1. So you can use a relation as 3 minus 1 by 3 plus 1, which is equal to 3 minus 1 is 2 by 4, that is 1 by 2 or 0.5 is the value of reflection coefficient. So if you know this relation, it can be either this, that is it can either they can either ask reflection coefficient or question can come from this side. So both these equations are very important. Please note this down. You don't have to go for the theory and reducing or anything. Direct equation is this and the answer for this question is 0.5. Question is this. For a single mode optical cable with a 0.25 dB per kilometer loss, this is the loss of the optical fiber, the optical power at 100 km from a 0.1 milliwatt source will be dash. So this value given is the input power, which is given in watt. So you need to find the output power. So the power input, if you take the value in dBm, it will be 10 log 10, 0.1 by 10 raised to minus 3. That is, this is the value in dBm. Okay, that is the power in dB with respect to milliwatt power. Okay, I have explained about this in earlier videos. So this is the power input in dBm. So if you solve it, you will get the value as minus this. You can write this 10 raised to, actually the value is 0.1 milliwatt it is. Okay, so you have to substitute it as 0.1 into 10 raised to minus 3, not just 0.1, I mean not this milliwatt, it is 0.1 milliwatt it is. So 0.1 into 10 raised to minus 3. So this 10 raised to minus 3 and 10 raised to minus 3 get cancelled. There is only 0.1, you can write it as 10 raised to minus 1, right? 0.1 can be written as 10 raised to minus 1. So it will be minus 1 into 10 log 10, 10. Okay, it will be minus 10. The answer is minus 10 dBm is the value of input power. I hope this conversion is clear to everyone. That is, I was receiving some doubts in the comment section that how to convert the power in dBm. Just take the 10 log 10 of the value in watts. This value is in watt, 0.1 milliwatt. So you can write this 0.1 milliwatt as 10 raised to minus 1 into 10 raised to minus 3. 0.1 is 10 raised to minus 1 and milli means 10 raised to minus 3. So you can write this as 10 raised to minus 1 into 10 raised to minus 3 watts. Or you simply write it as 0.1 into 10 raised to minus 3 watt. Later on you can convert this 10 raised to minus 1. And then to convert to dBm value, take 10 log 10 of this value. So it will be 0.1 into 10 raised to minus 3. That is 0.1 milliwatt. By, we need to find the value in dBm, 10 raised to minus 3. That is the power value when the input power, dBm power means it is a power value when the input power is taken as 1 milliwatt power. 1 milliwatt means 10 raised to minus 3. Okay, so this is the conversion. 10 log 10, 0.1 which is your input, 0.1 into 10 raised to minus 3 by 10 raised to minus 3. And the value obtaining is minus 10 dBm. Okay, so everybody will be knowing this. This is very simple conversion actually. But if you don't know, I'll just explain. Okay, so the power input obtaining in dBm is minus 10 dBm. Okay. Now, dBm means it is that power in decibel with respect to milliwatt power. So, that's why we have divided by 10 raised to minus 3. Okay. Now, we need to find the output power. So, power output is equal to power input minus path loss. Right. So, what is the power input? We have obtained as minus 10 dBm. Now, what is the path loss? Path loss is, that is, it is having a loss of 0.25 dB per kilometer. And what is the distance? Distance is 100 kilometers. That is, the loss will be totally 0.25 dB by kilometer into 100 kilometers, right? So, this will be actually the total loss. The loss is 0.25 dB per kilometer and it is traveling 100 kilometers or the distance is 100 kilometers. So, it will be 25 dB. Again, it is dBm. Now, we need to take the difference between this and this. So, I'm going to find the output power. Power output will be minus 10 dBm minus 25 dBm. And it is obtained as minus 35 dBm is the output power of this particular optical cable. So, just you have to find the value of given power in dBm. Then you have to subtract or reduce the loss, path loss. Here the path loss is given per kilometer and it is given that the distance is 100 kilometers. So, take the product of these two and subtract the value from the dBm value of power. Then you will be getting your power output. Here the correct answer is minus 35 dBm is the value of output power. For a class B amplifier providing a 20 volt peak signal to 16 ohm load and a power supply VCC is equal to 30 volt, the efficiency will be dash. So we need to find the efficiency of this class B amplifier. Okay, so we need to find the efficiency, and the equation for efficiency eta is equal to P out AC by, that is the AC output power by input DC power into 100. This much percentage will be the efficiency of this class B power amplifier. So we need to find the value of P out AC by P input DC. So before finding the power, let's find the value of voltages and currents. Okay, what is the value of the load current? It is providing 20 volt peak signal to 16 ohm load. So from this we can find the value of IL is equal to, that is VL by RL, right? VL is equal to IL into RL. So from that IL is equal to VL by RL, which is equal to, VL is 20 by RL is 16. It will be 1.25 ampere will be the value of load current. Now what is the value, DC value corresponding to this? It is 2 by pi into the given current. It is 2 by pi into 1.25 ampere, which will be 0.796 ampere will be the DC value of current corresponding to this load current. Okay. Now we have the values for IL as 1.25 ampere and the DC value of current for this particular load current is 0.796 ampere, and also the value or the equation for efficiency eta is equal to P out AC by P input DC into 100%. This much percentage will be the efficiency. So let us find the powers now. We have been given the VCC and also we know the value of the voltage of the signal. Okay, so first I am going to find the value of P input DC. Okay, it is VCC into IDC. VCC is 30 volt into IDC is 0.796 ampere. Okay, the value obtaining will be 23.9 watts is the value of P input DC power. Now P out AC is equal to VL, that is a load voltage, VL square by 2 RL. It is, VL is 20. So 20 into 20 by 2 into 16. And the value obtaining is 12.5 watt. 12.5 watt is the output AC power. So we have obtained the input DC power as 23.9 watt and the output AC power is 12.5 watt. So substitute in this equation directly, we can find the efficiency. I am going to substitute the value in this equation. Eta is equal to 12.5 by 23.9 into 100 and the answer obtaining is 52.3% is the efficiency of this class B amplifier. Okay, so the correct answer is 52.3 is the eta or efficiency. So for that you need to first find the load current, then find the DC value of current. You have to use the equation P out AC by P input DC. Find the values of the AC and the DC power separately and just substitute and find the value of efficiency. Okay, so the correct answer obtaining here is eta is equal to, that is efficiency is 52.3% is the efficiency. For an earth station transmitter, input power of 40 dB watt with a back-off loss of 3 dB, a total branching and feeder loss of 2 dB and a transmitter antenna gain of 40 dB. Determine EIRP. So what is EIRP? EIRP is effective isotropic radiated power. So you can think of EIRP as a power budget. That is, it is the sum total of all the gains and all the powers minus all the losses. That is, you can think of as a EIRP as a power budget. So it takes the sum of all the gains and powers and then it subtracts the losses from this power. So you will get the total EIRP of a branch or a transponder path or a link. Okay. So here the equation is EIRP or effective isotropic radiated power is equal to PT transmitted power plus gain. Here the gain of antenna is given, so the transmitter gain. Transmitter gain means a transmitter antenna gain minus back off loss minus the loss due to branching plus feeder. Here it is combined and given as, that is a total branching and feeder loss of 2 dB. So you have to subtract that also. It is a very simple question. Only thing is that you should know that what is EIRP and you should know what is the equation. So this is the equation for finding EIRP. Generally it varies depending on the various gains and various powers and also the various losses. So for this question these are the losses. For some other questions some other losses will be also included. So you have to subtract the losses from this total gains and powers. Okay. So here what is the transmitted power? It is 40 dB plus gain is again 40 minus back off loss is 3 dB. All the values are given in dB. So you just have to subtract it. That is 80 minus 3 plus 2 is 5. So the value is 75 dB will be the value of EIRP. Okay, so this is the EIRP for this particular earth station transmitter. Value of EIRP is not just dB, it is dB watt because it is a power, effective isotropic radiated power it is. So it is 75 dB watts. Okay, so this is the total effective isotropic radiated power. So these are the questions which I have included in this video. We'll be doing various parts for completing this question and answer discussion. And I really hope that these videos will be useful for your preparation for any competitive examination because we are doing a variety of questions while discussing these question papers. So if yes, please do give it a thumbs up and also share these videos with maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.